I wanted to make a quick comment about the solution to the first practice problem you did about head generalizations and the head in piezometers located along a flow path. Remember, this is what it looked like. And the key thing I want you to focus on right now is that this is actually right near a stream. In fact, we're describing the flow from the aquifer into the stream. And remember, when you looked at the solution, that I warned you that what I don't want you doing is simply filling up the piezometers so that they reach the level of the water table. I said that that's not wrong. Well, now that we understand the Dupuit assumption, I hope you can understand why that's wrong. Remember, the Dupuit assumption says that if you are far from a location like this, where the flow is horizontal, so the flow is horizontal, if the flow is horizontal, then the implication is that the head is not a function of depth. That is, the head is everywhere the same at every depth and therefore equal to the head at the water table where it's known. Horizontal. Okay, that's what the Dupuit assumption says. But the opposite of this also holds. That is, where the flow is not horizontal, then we would expect that the head will be a function of depth. And if the flow is demonstrably not horizontal, you can look at the flow line here in gray, and you can see that it's got a downward component over most of its path. And then once it gets past about here, it starts going back up, right? So almost nowhere along this path is the flow direction actually horizontal. And when it is not horizontal, then we would expect that the head at some depth will not be the same as the head at the water table or the elevation of the water table. So when we fill these piezometers, remember I told you it's really important that they do not just equal the head at the water table, and this is why. Now we can go a little further and point out that when there is a downward component of flow, so for example, all along this part of the path here, the water is in some way moving down. And when there is a downward component of flow, then the head at depth will be less than the water table. When there is an upward component of flow like there is here, then the head at depth will be greater than the water table. So to properly fill these piezometers then, we need not only ensure that the head continuously decreases, but we should also be making sure that along these paths where the water is also flowing in some degree downward, that the head is everywhere less than the water table. That's actually not so good. Let's try to do this a little bit. Less than the water table. It is below the water table in all of these piezometers. Once we get around here, the flow is nearly horizontal, so you could argue that the flow right here is essentially horizontal. And so here maybe is the only place, horizontal flow, that we can expect that the head in the piezometer at depth will equal the head at the water table. But once we enter the realm of upward flow, we now expect that the head again will not equal the head at the water table, but in fact will be above the water table, like I've drawn it here. So we've again satisfied the condition that the head continuously decreases from the starting point to the end point. But in addition, we've taken into account the fact that the head must be below the water table when there's some downward component to flow and above the water table when there's some upward component of flow. And when you look at the solution, it should now be glaringly obvious that it is not correct in this situation to simply locate the heads in all of the piezometers at the water table. This would imply horizontal flow, and you can see by the flow path indicated that the flow is not horizontal.